Welcome back to Aurora Tech Channel. Today, I'm going to test out the FLSUN Super Racer, which is a Delta 3D printer that comes with some really good hardware, including linear rails on all X, Y, and Z axes, a BMG-style dual-gear extruder, a dual cooling fan, a volcano-style hotend, a DWIN capacitive touchscreen, a removable auto bed leveling sensor, a filament runout sensor, a 32-bit board, and TMC 2209 silent stepper drivers. The diameter of this print bed is 260, and the maximum Z height is 330 millimeters. The machine is almost 1 meter tall, and it's an overall really interesting looking printer. As this is a Delta printer, the main reason we want a Delta is to be able to print fast. So, we normally won't see a direct drive extruder on a Delta, as we always want the print head to be lightweight in order to print fast. This means that not adding the extruder and the stepper motor to the print head of a Delta is a good idea. The manufacturer claimed the normal printing speed of this printer is 150 millimeters per second, and it can even print at 200 millimeters per second. I will push this printer over its limit to 300 millimeters per second and see how it handles that. I would like to thank FLSUN for sending me this machine to review, and with that, let's get started. We have the base, the top, a touchscreen, 3 long extrusions with linear rails, the extruder, hotend, bed leveling sensor, filament holder, 3 sets of parallel arms, and some tools. First, we will install the long extrusions at the top in an upside down orientation. These axes are labeled as X, Y, and Z, but since they're using the same stepper motor and linear rails, they should be the same no matter which one goes to which. However, I will just follow the label and use 4 screws to secure each corner. Next, put the base with the print bed at the top. We are still working on this with an upside down orientation. Use another 4 screws at each corner to secure the extrusions on the base. Then, slide in the touchscreen mount to the slot in the extrusion on the left. Use the screen to check and make sure the cable is long enough without being stretched too much. Now, we can flip it back to the normal orientation. Attach a set of parallel arms to each axis. Just snap it in, no screws are required. Grab the print head and snap the other end of the arm on it. It should be able to move freely. Next, connect the cable with the long black sleeve from the base to the top and secure it. Connect the set of cables from the top to the print head following the color on the connectors. Red is the heat cartridge, yellow is the thermistor, the 2 black cables are for the dual fan, the 1 white cable is for the heat sink fan, and the final cable remaining with the level label is for the bed leveling sensor. This sensor is only required once in a while when you do auto bed leveling. Then, hang the extruder and filament sensor assembly on the right side of the frame and secure it with 2 screws. Connect the Bowden tube from the print head to the extruder and push it in all the way and make sure the label touches the metal coupler. Connect the cable of the filament sensor, followed by the extruder stepper motor. Mount the filament holder at the top, load some filament, check the voltage, and we can now turn on the printer. The menu looks pretty nice. Let's start with doing auto bed leveling. Go to Tools, Auto Level, and select the Auto Level button again. The sensor is already connected, so select Yes to start. It's going to probe the center and the 3 points near the X, Y, and Z axis. Then, it homes itself again and probes 21 points on the bed. We can now remove the bed leveling sensor and adjust the Z offset. Press Move Z0 and the print head will move to the current 0 position of the Z axis. As the nozzle is too far from the bed, press the Adjust Z button, do the paper test, and keep moving the nozzle closer to the bed until it slightly scratches the paper. Then, select Save to save the Z offset. Let's insert the micro SD card and prepare for our first test print. Select Tools, Heat, and PLA. It will heat up the nozzle to 220 degrees Celsius, which is 20 degrees higher than normal, but as we want to print at 150 millimeters per second, we need a higher hot end temperature to melt the plastic fast enough to keep up with the speed. As I already inserted some filament, I will just select the extruder and press the in button a few times. Okay, the dark filament is coming out from the nozzle. Let's see what Gcode files are available on the micro SD card. There is only one testing Gcode, and I will just print it to make sure everything is working. It's a set of bolts and nuts. It took 40 minutes to finish, and they fit together very well. Next, I will go to my computer to set up this printer in Cura. Select Add Printer, Non-Network Printer, and we have FLSUN and the Super Racer here. Let's start with the calibration cube. Just use the default profile, except we don't need support. The print speed is 150 millimeters per second, with the first layer at 25 millimeters per second. Everything else looks fine, so let's print it. The print head is moving fast, and the screen is also showing the real-time print speed. Let's compare the one printed with an Ender 3, which used 30 minutes, and the Super Racer 14-minute cube. There is some ghosting on the Super Racer cube, as we normally don't print at this high speed if we have text on a surface. Besides that, the layer lines are looking better than the one printed by an Ender 3. Then, I will print a 3D Benchy with the same default profile. It only takes 45 minutes, which is very fast compared to an Ender 3 default 50 millimeters per second profile, which would normally take 1 hour and 50 minutes. Let's see if this printer can really complete the print in 45 minutes. It's quite impressive, taking exactly 45 minutes, and it's a very decent Benchy. The only minor issue I can see is that the cooling of this part is not enough. As you can see, the stock fan duct is a little bit too far from the nozzle and is blowing directly on the silicone stock instead of the nozzle. It would be better to extend the length by 2 millimeters and move it even closer to the nozzle. Another thing I would like to print is the filament roll. The super simple filament holder works okay, but I would rather let the filament spool sit on a round-shaped roller, so I will print a set of fan ducts and a filament roller and see if they work better. The length and the angle of this set of fan ducts looks much better. I put one of them on the print head, and you can see the angle and height is more optimal than the stock one. The filament roller also seems better. I will replace both fan ducts and reprint the Benchy. Both Benchies look really nice. When you look at the front part, the cooling is much better now. I will keep this setup and do more test prints. Next, I will print this Batman model. Generally, using an Ender 3 to print this model would take more than 5 hours. This Speed Racer only needs 2.5 hours. This model will be fine without supports, except for the nose. As you can see, this layer will be printing in the air, but let's print it without using support and see how it looks. The body looks perfect, and the layer lines are really nice as the base of this printer does not move, which can really improve the stability. As expected, the nose is not looking very good as this part was printed in the air, but overall this model is still a pretty nice print. Then I will print the Capitol Hill. This model will take 6.5 hours even with this Super Racer. Let's see how much time it takes with an Ender 3. The print bed of the Ender 3 is not large enough, so I will reduce the size slightly to 98%. It still takes almost 11 hours. So let's switch back to the Super Racer and slice this file. With a model that is as wide as the Ender 3 print bed, just using 6.5 hours to print with this print quality is very impressive. Afterwards, I will print this Thanos model, which will take longer than 29 hours on an Ender 3, and I never had the patience to wait for that, but using the Speed Racer can cut the print time by more than half. This print is beautiful, even though Thanos is very ugly. The layers, the body, and even when zooming in this close to the head are all just perfect. Additionally, I always wanted to print a lot of crates to tidy our workspace. This model requires more than 8 hours on a regular printer, even when printing at a 0.3mm layer height. With this Speed Racer, it can finish in less than 4 hours. The retraction is pretty good as a Bowden setup. There is only minimal stringing, and I'm very happy with the result and print speed. Besides PLA, I also tried to print PETG at the same high speed, but as PETG and ABS are not suitable for high-speed printing, after a few failed prints, I slowed it down to a normal 60 mm per second. Printing ABS on this glass bed without using glue is still alright. There is some warping at these two corners, but the overall print results of both PETG and ABS are great. Finally, I want to push the machine to its limits and even a little bit over its limits. I changed the stock 4010 blowers to more powerful 5015 blowers. Since the 5015 blowers are thicker and may touch the parallel arm when moving to the edges of the bed, I printed 2 adapters to raise them. I also put the printer on the ground to make sure the printer is sitting on something perfectly flat and sturdy. I tried it with different speeds, starting with 195 mm per second, then 225, and finally 300 mm per second. Here are the Benchy's printing at different speeds. The one printed at 300 mm per second still looks pretty good. I put all the links you need for this upgrade down below. After printing so many models this week, let me share what I think about this printer, starting with the pros. I like this printer mainly because it prints very fast. It prints great at 150 to 200 mm per second, and it still delivers reasonable print quality at 300 mm per second. The hardware of this printer is so good. The long linear rails on the X, Y, and Z axes run smoothly. The BMG clone extruder and volcano style heated block work pretty well and can print at 300 mm per second without issues. The glass bed is fixed on the base with 3 mounts. This is much better than the swinging bed on other Cartesian printers and results in better stability and beautiful layer lines. The leveling sensor works well. I just leveled it once and printed all these models without issues. As you only need the sensor once in a while, the attachable design is good as it allows you to remove some weight on the hot end for faster printing and just put it inside the drawer when you're not using it. The capacitive touchscreen is better than resistive touchscreens that you see on other 3D printers. It's very responsive. The user interface is one of the best, and the menu structure and button locations are easy to find. As for the cons, a Delta printer requires more vertical space than a Cartesian 3D printer, but the footprint of a Delta is smaller, so it occupies less space on the table. This printer supports both micro SD cards and USB drives, but it cannot support both at the same time. You need to reflash the firmware to switch from USB printing to micro SD card printing. It's not that hard, as you just copy one file to the root of the SD card and turn the machine back on to flash the firmware, which can be done in about 30 seconds. However, I have seen other printers that can support both at the same time, so I believe FLSUN should also be able to do this. Finally, the cooling system, including the fans and fan ducts, is not good enough to match the rest of the hardware. After I changed the fan ducts from the stock 4010 to 5015 blowers, it works great. The manufacturer could consider using a better cooling system in the future to improve the overall performance of the printer. In conclusion, this FLSUN Super Racer is the fastest printer I have ever tested. Its claim to print at 150 or 200 millimeters per second at the maximum is actually very humble. I tried printing with 0.2 and 0.3 millimeter layer height at 150 millimeters per second and didn't have any issues. I can also get good results printing at a 0.2 millimeter layer height at 300 millimeters per second with a simple cooling fan upgrade. If you are looking for a 3D printer that prints fast with pretty good print quality, you can check out this FLSUN Super Racer. I put the links down below. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week. The BMG clone extruder and volcano style hot end block were The BMG clone extruder and volcano style hot end The BMG clone extruder and The BMG clone extruder and volcano style heated block work pretty well and can print at 300 millimeters. It prints great at 150 to 200 millimeters per second. Millimeters per second, millimeters per second, millimeters per second, millimeters per second, millimeters per second. It prints great at 150 to 200 millimeters.